Starting in our third chapter on linear equations in two variable, we'll take a look at some quick vocabulary here. It should be mostly a refresher of the rectangular coordinate system, which is also called the Cartesian coordinate system, where we have an intersection at the origin of two horizontal and vertical lines called the x and y axis. We have four regions that are created by this intersection, quadrants 1, 2, 3, and 4, which start in the top right and move in a counterclockwise direction. Ordered pairs are what we refer to points on the coordinate grid using the notation of x comma y, where x is the distance along the x-axis and y is the distance along the y-axis. So what we can do is take a little bit of time to plot some of these points on a coordinate grid, remembering that the first coordinate is along the left and right axis, and the second coordinate is along the vertical axis. So the point 2, 1 means that we're going to start at the origin and we're going to plot 2 units to the right and 1 unit down in order to get our point 2, negative 1. Then our next point, 0, 5, we're not going to have any movement left or right. We're just going to move straight up 5 units. Then we have our point negative 3, 5. That's going to take us left 3 units and up 5 units. Point negative 3, 5. Then negative 2, 0, we're going to go left 2 units and stop there on the axis. Negative 2, 0. Negative 1/2 means we're going to go halfway to the next point and then go down 4 units. So we end up here at negative 1/2, negative 4. And for 1.5, 1.5, we go right 1.5 units and up 1.5 units to end up right here in the middle. And so we can look and identify what quadrant each of these points in. We see that the point 2, 1 is located here in quadrant 4. We see the point 0, 5, which is up here, is located on the y-axis. Negative 3, 5, that's located here in quadrant 2. Negative 2, 0 is on the x-axis. Negative 1/2, 1, 4 is located in quadrant 3. And then 1.5, 1.5 is located in quadrant 1. Now, solutions in equations of two variable are two numbers that form a true statement when they're substituted in for the two variables of the equation, usually x comma y. Those solutions correspond with the ordered pair points that fall on that line in the xy plane. So we can identify whether these points are solutions just by simply substituting them into the equation for our x values and our y values. And we'll do that one at a time. So we'll start with 3 times 0, that's our x value, minus negative 12, that's our y value, equals 12. Then we'll go ahead and solve and simplify. 3 times 0 is 0, minus negative 12 becomes plus 12, and this gives us a true statement. Therefore, 0, negative 12 is a solution. We can do it again with the next ordered pair. 3 times 1, where 1 was our x value, minus 9, which was our y value, to see if that equals 12. So 3 minus 9 does not equal 12. Therefore, 1, 9 is not a solution. We'll go ahead and evaluate the last one. 3, comma 2, where 2 is our x value, minus negative 6, which is our y value. So when we go ahead and simplify, we get 6 plus 6, and that does indeed equal 12. Therefore, 2, negative 6 is a solution. And what that breaks down to is that each of these solutions, the points 0, -12, and 2, -6, are both going to be points or ordered pairs on the line that could be graphed by 3x minus 2, or 3x minus y equals 12. And so down here we can see that that point, or that equation, is graphed on the coordinate grid by using those 2 points, 0, -12, as well as the point 2, -6. And we can see several other points that are on that line. So all of these points are solutions, and since every line has an infinite number of points on it, every linear equation has an infinite number of solutions.